All right, so let's talk about SQL injection. This is the one I wanted to demonstrate last week, but it wasn't working, and now it's working. So this is the one, SQL injection challenges. So we talked previously about command injection here, where you have something where the developer only expected you to put in an IP address, but if you put in an IP address followed by a command, it will execute that command. So now you get a ping, and then you get an ls, showing the serial on the server. So this is command injection, where I took data from the user, and the user was able to inject a command which ran on the server. And this command is running in bash, a command shell language. And so in SQL injection, you have the same problem, but the language you're injecting is SQL, which is less familiar with people. So first, I want you to just understand a bit of how SQL works. The whole point of SQL is to store data on a server and retrieve that data, and you store it in databases, and each database contains tables, and the tables contain rows and columns. So if you show databases, you'll see the names of the databases on the server. Here's where you can execute a query. And so this server has one database named widgets, which contains company data, and has another one named information schema, which is automatically created by the software, the MySQL server software. And because this is automatically created, it always has the same name, which is going to be real important when you hack into it. So now I can show tables. And I didn't specify which database, so it'll do the default database, and that's going to be in the widgets database. There's only one table in there, and it's called employees. So now I know the name of that table. If I was able to find the name of the database, I could then find the name of the table, and now I could get the data out of that table. The simplest way would be here, select star from employees, will give me all the data in that table. So now I get ID numbers, names, and social security numbers for various people. So that's what's in that table, and that's all there is on this server. Now you can do other things with a select query. You can select just a constant number, like 1, and then it will just echo back a 1 without actually fetching it from a table anywhere. You can also select a word, like peanut, a string, and this may seem useless, but it'll be useful later. Now you just get the result is peanut. And you can combine two words together with the concat function, which we're going to need. Right now this will combine peanut and butter to make peanut butter. All right. Now you can pick characters out of a string. This one will select a substring from the word peanut, starting at character 2 and giving me 2 characters. So the answer is EA. It picks those 2 characters out of the string. And this is important. We'll need this later also. And, all right. Now let's go down to this one. I can select a field from employees like ID. If I do that, I get just the ID numbers and nothing else. All right. I could also get the name from the employee's name. All right. And I could get both the name and the ID by doing name, comma, idea. And that'll get both facts, so name ID, name ID, name ID. So, all right. So that's how you do normal, simple things with, now here, the next thing you might want to do is you might not want everybody. You might want just the information about one user, which is what happens when you get your Gmail. You send up a cookie, it has everybody's mail, but it does a query to get just your mail and show you that, nobody else's. So it does something like this. It's going to get name and ID from employees where ID equals 1. So now I only get one person's data, which is normally what you want, so that one person is logged in and they only see their own data. Now you can have a complicated query like this, which combines a few of these things together. So this is going to concatenate name and ID together into one field from employees where ID equals 1 or cat equals dog or 2 equals 2. Now let's take this off first. Without this, I have a compound condition. There's one record where ID equals 1, and cat never equals dog. And if you have one condition or another, if either one of them is true, the answer is true. It'll be successful. So this will give me the same person, just one person, the person with ID equals 1. But if I add this part to it, or 2 equals 2, then I have one condition which is true sometimes, one condition which is never true, and one condition which is always true. So this compound conditional is always true. So now I get all the data. This is going to be very, I said the where clause, which limited it, does not actually limit it because this is always true. So I get all the data. All right. Now, let's talk about getting into the built-in tables. We saw that there was this thing called information schema, and you can get all the information schema tables this way. This keeps track of it, and this tells you a lot of information about the internal fields that are stored as the database runs. This is the database software creates all these formats, version and engine and all that jazz. So that's internal data. What's more interesting to us, all I really want is the table name. I don't want any other information, so I want the table name from information schema tables. This will give me a list of all the table names. And you see, it has a bunch of internal tables created by MySQL, and then at the end, it has the one which is has company data in it. All these just have metadata, like parameters of the SQL software running. This is what actually contains data that's probably of interest, like passwords and credit card numbers and social security numbers and such. So now I can get all the columns as well. Select, if I can only get this thing to select instead of screwing up on me, or select column for information schema columns. All right, this will give me columns. And again, there's a tons of automatically generated columns that are not interesting, but at the end, I have the columns that are used by the company, ID, name, and SSN. So now I know the name of the table, and I know the name of the columns, so I can dump out that data. And so you can also specify it to look just in one table with a where clause, but that doesn't matter so much. So here's some challenges. You can use those queries to find the answer to a few things here, and that's in the first section here. This thing has 3 sections, and you can reset the server here, and there's a box in each one. So you use the box in this session to answer the questions in this section. So now this shows you how SQL works, but you would never let a customer have access to this. This is what the database administrator has. If you let someone run arbitrary queries, they can delete the data, they can change the data, and that's what you want for your database administrator, but certainly not for your customer. Your customer should only be able to change their own data and things like that. So you never let a customer have that field. What you'll give a customer is a field like this. Let me just reset this server and go back. All right, here you can search for someone by name. So I can search for Bill Gates. This is something you'll find in every website. You can search for things. So I can search for Bill Gates, and it finds Bill Gates. So that's fine. If I search for somebody that's not there, like Sam, it doesn't find any because there's nobody named Sam. So this is a normal search working correctly. Now you'll see the problem if you put in a name that contains an apostrophe. If I search for this name, I get a weird error. I get an error in the SQL syntax. This is the kiss of death. This means you have SQL injection vulnerability and you can take over, can hack your database. Because what happened here is, this is the query. Select name from employees where name equals, the developer put that in. This code came from the user. But this line was parsed where this apostrophe matched that apostrophe. Not this one that came from the developer. So it found tip O, that was the name, and then it expected a SQL command here like or and or something, and it found an unfamiliar word and a hanging apostrophe, and that's why there's a syntax error and it crashed. So this has caused the query to crash, and if I put in something more careful here, I can execute code on the server. So this one here is the simplest one. Now we know already, if I search for Sam, there's nobody named Sam, but if I do this, with the apostrophe in it, now I get everybody. And the reason I get everybody is because I put in this name up to the pound, and that caused the server to interpret it as name equals Sam, which is never true, or 1 equals 1, which is always true, and this pound is a comment character, so it ignores that extra apostrophe, and it doesn't cause an error. So now I've made a condition that is always true, and I get all the data. However, I'm only getting names because the developer wrote this code and I can't change it. So I'm getting names, but I'm not getting social security numbers. So this is an attack, but it's not a terribly powerful attack yet. But I can make it more powerful by doing this. The union command lets you add another whole query to the previous query. So if I do this, it's going to run this query where name equals Sam and find no results. And then it's going to add to it the results of this query, which selects 1, so I see the 1. And the point of this is now I have turned this box into this box. Remember I said this one is so powerful, a customer should never have this power to run arbitrary queries starting with select. But I can now do that here by putting a select query in my name field with this structure. So now I can run ones up here, like select star from employees. I can run that here. Now I'm going to get another error showing the problem is I have a different number of columns. The query that the developer wrote only has one column. It only selects the name. My query selects name, ID, and SSN, or 3 things. So I'd have to either select one thing at a time or concatenate them. So I could try select SSN. If it's in the employees table, we'll see. And there they are. And if there's a name, I know there's a name in there too. So I could do a concat of SSN name. And then I get them. So, it's just a question of learning how to write in this strange language, and you can pump out anything. And this is very common. Until about 3 years ago, this was the way almost all stolen data was done on the web. More than 90% of all stolen data was stolen from SQL injection because you don't need much skill. All you need, and you don't need any special tools. You just go to a website and you put weird things into like the search engine like that, and you do it right, and all the data comes out. This was the worst vulnerability on the web until about 4 years ago when Amazon put up EC2 buckets, which by default were world readable. And then I think they lost even more data because people put their whole database on the cloud and not know that the whole world could read it. And that tons of data came out that way, which was even easier to steal than this. All you had to find was the URL, and then you'd see all the data. So anyway, there's things to find here. Now, if you're a professional pen tester, if you're taking the 123 hacking class, then you won't be doing SQL injection manually like this. You'll use this hacking tool, Sqli map. And so if you want to, you can try that. But that's mainly, AWS S3 buckets. Those things were by default world readable for years, and people just lost a ton of data that way. So anyway, Sqli map is a hacking tool that will automatically do all these queries for you and take the data. And I have a few challenges here for that. But I wouldn't bother with them unless you're taking the 123 class. But the last thing I want to show you, which is very interesting, is blind SQL. Now, this SQL injection here, I was able to steal data, and the reason I was able to steal data is because the query got data from the database, a name, and then it printed out those names. So this is normal SQL injection where the developer's code displays data from the database. And all I have to do is trick it into displaying other data from the database. But there are cases like, for example, a login form. You send it a name and password, and it says, okay, you're logged in. That login page might not contain any data that came from the database. It could just be a message saying, okay, you've logged in. So a query is run to decide if your password was correct, but you don't see any data that came from that query. And that's what's going on in blind SQL injection. So if you go down here, I can search by name again. So I put in Bill Gates. It finds Bill Gates. Okay. And if I put in Sam or X for something's not there, like X, it doesn't find it. So far, it looks the same as the previous one. But now, if I try to do a SQL injection here, this is one of the ones we've done before, X with 4 apostrophes, so it won't make them unbalanced. Now you can see I've made name equals X or A equals A. So that should always be true. So I would expect to see all the names. But what I see is my query, not the results. This developer did not print the name that came from the database. They printed the name I fed in. However, I can still learn what's in the database by doing a series of queries. Notice here, If this condition is true, this combined condition, then I get a result. If this condition is false, I will not get a result. So if I make that A equals B, which is false, now I get no result. So I can ask a yes or no question. If this condition is true, I will get an answer. If it is false, I will not get an answer. So now I can gradually narrow in on things. So if I wanted to know the length of the database name, here's something that will tell me if the database length is 1. If that condition is true, I'll get an answer. Well, it's not true, so I don't get an answer. That means it's probably greater than 1. I can put greater than here. And now it's true. So by trying different values, I can find out how long it is. And by using substring, I can pick out one character. And you can spell things out this way, and it doesn't take as long as you might think. For example, here, if I wanted to find a name or a password or something, this is the kind of injection I would use to do that. This will, now I've done a union, so I have a second query. That's going to select name from employees, where name equals Bill Gates. And now I'm just going to use the name. I can take the first character of the name and say, does the first character of the name equal B? And it does, so I get an answer. Now, if the first character of the name was wrong, like if I put an A here, then it's false, and I get no answer. And if the password was in here, I could change this to substring of password if I find it. So all right. So this is so you can pump out information bit by bit this way, and it doesn't take as long as you'd think because you can use greater than or less than. You don't have to try A, B, C, D. You can just try greater than equal to M, greater than equal to J, greater than equal C, and narrow it down by splitting the thing in half every time. So there's various challenges here to find, and that's what I wanted to show you. This is SQL injection, and like I say, learning how to do it by hand is good to understand it, and we'll have more examples in the Web Security Academy, but what most professionals do after you understand it is you use SQL Map or another hacking tool that automates all these processes. All right, let me stop this recording.